Okay, let's get started with 1/6 polynomials and rational inequalities. So we're actually going to just do half of this. You will not be responsible for solving rational inequalities, just polynomial inequalities, which we will learn about right now. To do this, we're going to have to understand zeros and test intervals. That's going to be the big topic for this section. Since we're not doing rational inequalities, we don't need to worry about that. All right, so in summary, what do we need to do here? You know what? We can skip this because that's going to be repeated shortly. So let's dive right in. A polynomial inequality. So we remember a polynomial has a number of parts. In this case, this is a trinomial, and those are the ones we're going to be focused on for this section. So normally, if we were to solve this with an equal sign, we would need to factor it. So we factor this. What multiplies our AC is -2. Our B is 1, so what multiplies to -2 and adds to +1? That'd be a 2 and a -1. And since it's a 1 for our A, we can put a 1x underneath both of these. And so there's our parentheses, x plus 2 and x minus 1. And so to solve this, we would say x equals -2 and x equals +1. All right, we can represent that on the number line by 2 and -1, and a little dot right here representing those. So what we're going to do in this section is not deal with polynomial equalities, but inequalities. So what we could do is, what if this problem was saying less than? All right. So if all of this was less than 0, the way we're going to solve this is we're going to test the intervals. So on our number line, -2 and +1 splits our number line up into 1, 2, 3 sections, right? So what we need to do is we need to test all of these sections. So we're going to pick an easy number from each section to represent all of the numbers in that section, all right? So let's say 0 for the middle one, because 0 is a really easy number to check. Let's go plug it in. So our factored form is x plus 2 and x minus 1, okay? All right, so if we plugged in 0, 0 plus 2 times 0 times -1, that's 2 times -1, which is -2. And so what we need to do over here is, because we're comparing it to 0, we really only care if this number is positive or negative. So if we plug in 0, we get a negative as the result. Okay, let's plug in something over in this region over here. I'm going to pick the number 5. Any number will do. Okay, just pick an easy number to plug in. So instead of x plus 2 times x minus 1, we're going to plug in 5 plus 2 and 5 minus 1. 5 plus 2 is 7, and 5 minus 1 is 4. If you multiply those things together, you don't actually care what the result is. You just care about whether it's positive or negative. And 7 times 4 is positive 28. Let's try a negative number. How about -5? So we plug this in. So we have -5 plus 2 and -5 minus 1. So we would get -3 times -6. That's positive 18. So we'd have a positive in here. All right, so this section is positive, this section is negative, and this section is positive. Okay, if the problem said we wanted it to be less than 0, we want our answer to be negative. So if the inequality was a less than, we would only want this region. If we flipped it around and said we wanted it to be greater than 0, we would want the positive. So we would not want this region, we would want just this region. All right, so let's try a couple examples to see how this works. So I think we're going to do 4 examples, then you'll try 1. I think in the examples you'll get a better sense of what's going on here. So the 6 steps that I just did are right here. I actually didn't write this in interval notation. I'll do that on the examples. But if you want to pause the video and get those steps down to help you along, please do that. Otherwise, we're diving into the problems. So here we go. So step 1. We need to write the inequality in standard form. That means getting 0 on one side. X squared minus x, let's minus the 12, so that we have 0 on one side. Then we need to factor. This will be x minus 4 and x plus 3. All right, that was step 2. Let's look at our steps again. Draw the number line with the label, the zeros labeled. So negative 3, and positive 4. Right? Negative 3 from this parentheses, positive 4 from this parentheses. Okay, determine the sign of the polynomial in each interval. So this is where we have to test. So again, I'm going to test 0 because 0 is really easy. I'm going to test negative 5 and positive 5. Could be negative 10, positive 10. Either one would work. So instead of x minus 4 times x plus 3, I'm going to try, let's start with the negative 5 first. Negative 5 minus 4 and negative 5 plus 3. Negative 5 minus 4 is negative 9. And negative 5 plus 3 is negative 2. Multiply those two things together, you get a positive number. Let's try this with 0 minus 4 and 0 plus 3. This is a negative, and this is a positive. So if I multiply them together, I get a negative. Again, I don't really care what the number is as the result. I just care about the sign, positive or negative. And then lastly, let's plug in 5. So we have 5 minus 4 and 5 plus 3. 5 minus 4 is a positive, and 5 plus 3 is a positive. Positive times a positive is a positive. Okay, what do I want my answer to be? I want my answer from here to be greater than 0. That means I want my answer to be positive. Okay. So which sections do I like? I like this section, and I like this section. So how do we write those sections? This section is all of the numbers that are less than negative 3, and I want all the numbers that are greater than 4. Okay? And so to finish this up, we're going to write this in interval notation. So we'll say negative infinity, negative 3. And we're not touching. There's no equal sign, so parentheses. We're going to say 4 all the way up to infinity. And something new, if we have two different sections, we're going to connect them with a U in the middle. This stands for the union of those two, but you don't really need to worry about that. Just use the symbol U if we're saying that section and that section. All right, let's try one more example. X squared less than or equal to 4. Let's get this in standard form. X squared minus 4. We're going to factor x minus 2 and x plus 2. Less than or equal to 0. So the important numbers on our number line are negative 2 and positive 2. So let's test negative 5, 0, and 5 again. So instead of x, plug in negative 5. And we get a negative and a negative, so that's a positive. If we plug in 0 minus 2 and 0 plus 2, that's a negative, that's a positive, so we get a negative. And if we plug in 5, 5 minus 2 is a positive, and 5 plus 2 is a positive, so that's positive. We need to be less than 0, so we only like this section. So we're going to say negative 2, less than or equal to x, less than or equal to 2, bracket negative 2, comma, positive 2. All right, we have x squared plus 2x plus 3 when we move it over, greater than 0. So if we factor this, 2 and x plus 1, I'm sorry, x, positive or a negative? Because this would need to be a negative for this to work. So I'm going to assume that this is a negative. So we're going to say x, nope, I apologize. X plus 2 and x plus 3, you're going to need to use the quadratic on this one. Oh, you know what? I had in my notes to cross this example off. I don't want you guys doing the quadratic to solve these. I just want us to focus on factoring for this. Okay, so cross that example off. On we go. So again, with a quadratic inequality, don't worry about this one. Nope, this one we can do. Don't have to use the quadratic formula. X squared plus 5x is greater than 0 when you bring it over. This is factorable by pulling out an x, and x 5. So our zeros are 0 from here and negative 5 from here. All right, so let's find some inequalities. In this one, we can't use 0 because 0 is already on our number line. So how about negative 2? How about positive 1? And how about negative 10? Okay, so we'll plug this in. Instead of x and x plus 5, we're going to say negative 10 times negative 10 plus 5. That's a negative times a negative, which is a positive for that section. How about negative 2 times negative 2 plus 5? That's a negative times a positive, so a negative in there. And then 1. 1 times 1 plus 5 is a positive times a positive. So we want to be greater than, which means positive. So we like this section and this section. So x is going to be less than negative 5. And x is greater than 0. So how do we write that? Negative infinity to negative 5, union 0 to infinity. All right, one for you to try, and then we'll do a bunch of these problems in class as practice. Hopefully we got x squared minus 5x minus 6. After that, we're going to say x minus 6, x plus 1. 6 and negative 1 are numbers. Let's use 0, let's use 10, let's use negative 10 as our test. So negative 10 minus 6, negative 10 plus 1, negative and a negative, positive. 0 minus 6, 0 plus 1, negative and a positive. And we'll say 10 minus 6, 10 plus 1, that's positive, a positive. Positive in there. We want to be less than 0, so we want to be negative, so we will say negative 1 is less than or equal to x, less than or equal to 6, bracket negative 1, comma 6 bracket. All right, we'll do more of these in class. See you next time.